In this section, we're going to take a look at sampling and sampling techniques. And there's actually a number of different ways to collect samples. Ultimately, the whole idea of being able to collect samples is several. Um, in general, you want to make sure that your data selection is random. And when we say random, that means that there's no outside influence or you're not predetermining what types of samples you're looking for. You're just trying to get data that is just essentially going to be any sort of place, any sort of time, right? The other thing that you'd like to do is you'd like to make sure that it reflects the characteristics of the population. And so, for instance, if I wanted to figure out what the average GPA of a Hartford Community College student was, I would not ask just my honors program students, or I wouldn't just go into one specific class and ask. I would try to utilize a variety of different samplings to be able to get the different reflection of the entire campus. So whenever you're thinking about trying to gather sample data, make sure that it's random and make sure that it does reflect the characteristic of the population. In other words, unbiased might be another word that we try to utilize. So given these different types of ideas, let's take a look at some different ways of collecting data. Now, if we could put every observation in a hat and just randomly select maybe 5, 10, 20, 100 of those, that would be called simple random sampling. A simple random sample is essentially saying every observation in the population has an equal likelihood of being selected. The problem with that is that we have to get all of them together in one location. And sometimes we don't know what the entire population looks like. And so if you don't know what the population looks like, then maybe what you could do is you could get a subset of the population or a sample. And then what you might want to do is use a predetermined algorithm, maybe picking every third person, or maybe every person whose last name begins with O, or something to that effect. Right? That's called systematic sampling. So systematic, obviously that word is essentially going to mean that you have some sort of system or algorithm. And systematic sampling just says I'm going to pick every third person, or if a person's last name begins with I, or something of that nature, we have a system of selecting observations. What if we put the observations into categories or classes first, and then maybe we pick 2 or 4 from each of those different categories, all right? That's called stratified sampling. Stratified sampling suggests that we actually have to put them into categories, which might take a little bit more work, but it might be more reflexive of the population. So for instance, we could put them based on income, age, major, and then maybe we could select maybe 3 people from each major, or 3 people from each different income bracket, or 3 people from different age bracket. That's your stratified sampling. You're putting folks into, or observations, doesn't have to be people all the time, but we're putting these sorts of observations into different classes or strata, and then we're selecting 1 from each. What if we're not selecting 1 at a time? Maybe we're selecting 2 or 4 at a time, right? That's something called cluster sampling. So a cluster sample, we're not putting people into any sort of group, all right? So we just have maybe 100 people, and I'm going to pair up 4 people, and I'm going to pick those 4 in a chunk. And then I'm going to pick another 4 people in a chunk, and another 4 people, etc. And now I have a sample of 12, and that's a cluster sample. And I'll show you a diagram in a few moments of this. Right. Sometimes we don't really have time to be able to think about what our population looks like, or even get a good random sample. Sometimes we just need data that's going to be most easily available. That's called convenience sampling. And a convenience sample is probably not the best way to go, but you use whatever you have in front of you. All right, so that's basically you're at a deadline, you need something quick to represent the population. There's probably going to be a lot of variance as to what's going on, but at least it has some barometer of what to expect. I would suggest not using a convenience sampling unless absolutely necessary. Right. The final method is actually a permutation or a combination of all the methods that we've looked at before, and that's called multi-step. And a multi-step sample suggests that we might first stratify, and then we might systematically pick maybe every third person within each strata. Or we might group people according to major, and then might have a cluster of 2 from each major. So essentially, it's coupling 2 or more of the previous 5 different methods together. A lot of times, to ensure randomization, a multi-step sample might be the best way to go. However, that does mean that you're going to have to do more work. All right, so it's basically, do you have the time and the resources available to perform a multi-step sample? Just some diagrams as to what the different sampling techniques might look like. A simple random sample, let's say we have a population of 12 people and they all have different characteristics. So maybe the colors represent a different characteristic, like a major. So maybe blue indicates a science major, brown represents an arts major, and maybe green represents an education major or something like that. And so we just randomly pick, all right? We just don't have any rhyme or reason, but we throw all 12 people's names into a hat and we just pick 3 of them. That would be a simple random sample. Stratified sampling. First of all, what we do is, remember up here we had our 3 different types of majors. Maybe we had science, education, and then arts. So we group them into those 3 majors. And then what we do is we just maybe pick 1 or 2 out of each of the different groups to try to get a diverse sample. Okay, so that's a stratified sample. Systematic sample, maybe I line them up according to however the numbers were drawn or however I assign the people or the objects. And then maybe I just pick every third, starting with the second observation. All right, so I pick 2, 5, 8, 11. All right, so I'm picking every third of the observations after I start with number 2. And just a diagram as to what cluster sampling looks like. Cluster sampling is essentially going to be, we're going to group people into 2s. All right, so we have those 12 people that have different majors. We group them by 2s, and then maybe we take one group of 2 and then another group of 2. All right, so those are maybe just some images that might help you to define the different types of sampling that are going on. So how do we go through and try to determine whether there really is some sort of association going on between some sort of characteristics? So in other words, do we truly know that as somebody gets older, there's a decrease in their bone density? Well, we have to know that because we've observed it. Or perhaps we've induced some sort of treatment into the group, and we can see over time that some sort of medicine is taking effect on people. And so the difference between an observation and an experiment. An observational study, and we're just going to say observation for short, measures characteristics of a population by studying, but not trying to interfere or manipulate with any of the different variables or the characteristics. So basically, in an observational study, it is what it is. We sit back and we watch and we record what happens. We don't induce any sort of treatment. An experimental design or an experimental study, and I'm just going to say experiment for short, we induce some sort of treatment, and then we try to determine whether that treatment really does have an effect. Or in other words, there's a response to it. So we have a treatment on some sort of observation, and we're looking for the treatment to induce a response of that nature. Now, let's talk about the different types of observational studies, because observational studies are usually a little bit easier to do because we just sit back and watch. The first type that we have is where we just take a snapshot in time and we just take a look at maybe a couple different groups and we observe what's going on at a specific point in time in that group. That's called a cross-sectional study. So cross-sectional study is essentially what it suggests. You have 2 or more groups and you're trying to look at some sort of characteristic about that in some point in time. So for instance, maybe we're looking at group 1, group 2, and group 3 having different majors, and maybe we're looking at the GPAs of those different majors. Maybe one major has a higher GPA and not, right? Now, this is a very easy sort of study to induce because all we have to do is just ask a question or do our research. But unfortunately, the type of the data that we're going to get is usually not reliable because it's only one instance in time. And as we know, a lot of people's GPAs fluctuate as they go throughout their academic careers. So maybe you collected 10 education majors that initially had a 3.8 GPA, but as their coursework went on, it got a little bit harder. And so over time, maybe their true GPA average might be something like 3.4 or something like that. So we have to take into account that there is a dynamic effect that's going on. And so another type of study that we can look at is something called a case control study. Now, a case control study is another observational study, and it compares individuals with a particular characteristic. Now, that group is called the case, all right? And we compare those to people that do not have that characteristic, all right? And what we do is we ask them to recall effects of something that happened to them. And so, for instance, maybe we suggest that we have 10 education majors and 10 science majors, and we ask them to recall their GPAs over time. Now, this is called a retrospective study, which means that the observations or the subjects have to recall what actually happened. And of course, that's subject to their honesty, that's subject to their clear and also cognizant recollection of the events. So in other words, maybe somebody says, well, I really had a 3.8, but they didn't have a 3.8. Or maybe they had a 3.5 and they report 3.05 by accident. All right, so these case control studies aren't always the best way to go, but they're generally a little bit more effective than a cross-sectional study because you get a multitude of responses that to kind of populate your sample. Now, the most effective type is something called a cohort study. And a cohort basically takes a group of individuals from some beginning point and we just study them throughout time, all right? So in other words, if we took a look at 10 education majors at the beginning of their careers, and then we just kind of track those over semesters, we can see what happens to those students over semester 1, 2, 3, 4, 5. It's a cohort study, and we look at all 10 of those. And what that tries to do is it tries to norm out any sort of extreme values as well. So a cohort study, if you're doing an observation, is probably the best way to go, if at all possible. This is called a prospective study, which means that you start at the beginning and you're moving forward instead of retrospective, where you're kind of asking the participants to recall what actually happened. The only downside to a cohort study is that it does take a long time to do, and it might involve some extreme costs. In other words, we have to track these people, so we might have to hire somebody to be able to track them. Rather, with a case control study, you could just ask them one time. What are we trying to look for whenever we do some sort of either an observational study or experiment? We're trying to look for some sort of association or even a correlation, all right? So when we talk about the idea of causation, now you've probably heard the word causation before. Causation is a relationship between two variables and the degree of the strength between those two variables, all right? And causation means that it absolutely happens, all right? But unfortunately for us, causation is not measurable by an observational study, all right? So we can't say causation. What we can say, though, is that we can say association, all right? So whenever we're talking in terms of statistics, we cannot say for certain causation. We can say for certain an association, an implied sort of relationship, all right? So again, observational studies do not allow us to claim causation. Okay, so we cannot say that over time, GPAs tend to get lower as courses get more difficult, okay? We can only say that the data suggests that that happens to a sample, okay? So we can only claim associations. All right, so be careful with your terminology whenever you're trying to do some sort of observational study. You always want to use the word association instead of causation. Now, sometimes there's these variables that really are affecting two different types of variables, but it's not necessarily acknowledged or it's not known. That's called a lurking variable. A lurking variable is a variable that affects both the variable of interest but is not known or acknowledged. All right, and here's an example of that. Okay, so let's say I work 80 hours a week and I drink a lot of coffee to keep me motivated. Now, let's say for some reason, I interview people that drink a lot of coffee and work 80 hours a week, and the people that drink coffee experience burnout. Okay, is it fair to say that people that drink a lot of coffee experience burnout? Well, it is possible because usually there are people that drink a lot of coffee to keep them motivated if they do work a lot because it helps pep them up from the caffeine. But really, the lurking variable is not necessarily the coffee, but it's how often they actually work in a week. All right, so it's really the 80 hours a week of work in a week that's causing the burnout. All right, so that's what we mean by a lurking variable. Lurking variable basically means that there's something else going on that we're not necessarily recording. So maybe we're looking at people that drink a lot of coffee, but we're not looking at the fact that all those people that work 80 hours a week drink a lot of coffee. So be careful when you're doing these sorts of observational studies. Sometimes there's an underlying sort of variable that happens to actually cause the association. And finally, in this section, just a few different diagrams. A cross-sectional study, we're just looking at one instance in time, and we're just taking groups and we're measuring what happens in the groups. Case control, we're taking maybe 2 or 3 different groups, we're asking them their history, and then we're drawing a conclusion after we compare. And then with a cohort study, we're basically taking different groups, we're letting some time pass, and then we're comparing the results of that after time. Great. So in the next section, what we're going to do is we're going to take a look at the different effects of errors and how error might be involved with the different types of sampling that we're going to be looking at.